Okay, so sound masking, this is kind of more for our commercial applications, our office spaces. You don't want to put the walls to deck. You know, it takes a lot of extra time for the MBP subs to punch through all the drywall, or the drywall sub to build around the ductwork and the conduit. It saves a lot of cost for all the extra work as well. But it gives you speech. It does two things. It gives you speech privacy in the space. People can't hear what you're saying. So for HIPAA compliance, financial, insurance, legal, all those times when you have confidential information, HR departments, you need to make sure that that information is confidential or private. But beyond that, it also helps with reducing distractions. You don't hear that somebody drop a book or cough, or they're on a call. You don't care what they're saying, but it's just annoying to be constantly distracted by their speech. How that works is with dynamic range. Okay, one thing we see a lot of is, excuse me for one moment. People see sound masking, they think it's more like a sound vacuum cleaner. Like it's gonna suck up noise and make it a lot quieter in there. And it does quite the opposite. What it does is it raises the floor in the room. Okay, so all those times where it was quiet, this is a 120-second or 2-minute average of sound. The first amount of sound was this background sound, people talking, the air conditioner, the toilet water running, the refrigerator compressor, all those kind of living components of a building. And it goes up and down, traffic nearby, airplane traffic overhead. Well, what happens is right here, the first time at 65 seconds, it was quiet, nothing was happening, and then somebody dropped a book. Bam. And everybody in the office looks over there because there was a moment from 40 decibels all the way up to 65 decibels within 1 second. That's a huge dynamic range. And range, as you guys know, is max minus min. Very quickly, you went from 35 to 65, a 30 decibel jump or so. That's going to distract anybody. Whereas the second time around with this blue line here, sound masking is being pumped into the room, okay? That doesn't make it quieter. It just means that it was never 35 decibels at any moment. It was never 35 dBA. It was always 45 dBA in the room. There were no quiet moments. So when somebody drops that book, it goes from 45 to 65, still distracting, but no longer alarming. And now when somebody picks up the phone here, there's a, 8 dBA jump. 8 dBA is not even distracting anymore, or it's kind of the limit of distraction. So you're cutting down on all of those constant distractions that are happening throughout the day. That #1 noise complaint in office spaces in America is #1, privacy. They can hear what I'm saying. And #3 is I can't get any work done here. I'm constantly distracted. When they're saying distracted, this is what they mean. Those constant dynamic jumps of course, it's people butting in and asking questions as well. But it's hard to get work done when there's constant distracting noises happening around you. Sound masking systems, here's how they work. There's downward firing ones like Cambridge that go in the ceiling tile downward facing. There's upward firing that go above the ACT and hit the deck and then kind of rain down homogeneously. That's what we generally prefer for a number of reasons. You have spatial homogeneity, like you're not walking around saying, oh, there's a speaker, there's a speaker. You just have constant coverage everywhere. It keeps you from getting hot spots. And that's not what you want. Air conditioning could basically be sound masking if you don't mind hot spots. But air conditioning is not effective because it's loud here and it's quiet there, or it's loud now and it's quiet later. This is just all the time, constant 48 dBA in an open office, constant 43 dBA in a closed office. Needed for Department of Defense applications, needed in hospitals especially. I mentioned hospitals earlier. You can't just put wall blocker on a wall and think that's going to fix all your issues if your nurses are keeping the doors open so that they can maintain line of sight on the patient. If the patient has altered mental status, if it's a semi-private, AKA shared room in the hospital. None of that, wall blocker in the walls and an STC rated door doesn't fix anything. The door's open. What you need is sound masking. Very common in a lot of educational settings as well. If you have faculty rooms next to each other, but especially open offices, especially libraries, sound masking can be that panacea of, hey, using Leanr, using these upward firing speakers in this space can make a big difference in the sound masking or in the acoustic performance of the space. Okay, jump into the last part now. We've got just a moment or a minute or two left. Consulting. Sometimes ABC, absorption blocking cover, or sound masking, we call it ABC. Sometimes that's not enough. So we call our core competencies ABC squared. That's when, you know, a product or a system or a solution alone is not going to solve your problem. You really need to say, hey, this machine is loud. This machine is shaking the building. We've got a railroad next to this hotel. How do we fix that? Very limited options on that. But can we place this hotel so close to the railroad? You know, tough decisions you have to make. And sometimes consulting is the only option. Sometimes you're looking at glazing systems or curtain walls next to a busy park. You know, what thickness glazing do you need? And that takes a lot of in-depth analysis at 80 hertz or 63 hertz, one-third octave band. Is it too noisy there? Do you provide review and acoustical recommendation specs? Absolutely. Thank you, Beth. Yes, and that was not a canned question, by the way. That's an actual question. So we do design assist for free. Commercial Acoustics does, and which means that we work with the architect and say, hey, your target SDCs need to be this. You're already hitting it on wall types 1 through 7. Wall type 8, you really need a membrane here or a different wall assembly to achieve your number. And that's where our cheat sheet of rated wall assemblies comes in. So yeah, we do that free of charge. On the other hand, if you've got an AC system or a pump room and you're like, hey, how do I mount this? I'm looking at Kinetics mounting or Mason Industries. Well, then we go in there and we say, hey, here's the exact type of space you need. And that would be a consulting engagement. 2 different parts of our company. There's ABC, which is solutions oriented. There's consulting, which is more of a long-term engagement of here's how you need to design your building. And based on the complexity of it and the potential solutions, that's whether it's a free design assist or a consulting engagement. And if you're not sure, Nick's on the call. I'll be available after the call today. Just reach out to us and say, hey, what's more appropriate in this situation? A lot of times we do field testing. Hey, I finished this high-end condo. Look at this LVT on the open web truss. What's wrong? I'm getting tons of noise complaints. We work with developers all the time and architects. Sometimes we work with the unit owners. Okay, this is what a tapping machine test looks like, dropping little hammers on the floor in a calibrated way and measuring. You measure below and you say, hey, why was I only getting a 38 instead of a 50? Well, look what the architect accidentally specified was hat channel. And that's a very common mistake. Hat channel is not resilient channel. It's nowhere close. It might look the same, but resilient channel on the underside of open web truss running an orthogonal or perpendicular will get you 10 points. Hat channel will get you 0. And so in this case, they used Acoustimat 1 under the gypcrete, under the LVT, and nowhere else. So they have a ton of flanking around the LVT. And they use hat channel on the bottom side. They were getting an IIC 33, a field IIC 33. And that means that they cannot lease this apartment. They can't lease any of these. The entire system or the entire apartment complex was having major noise complaints and having a very difficult time getting any renters. And for good reason. So, and that's the kind of thing that's, it cannot be fixed. There is no going back to fix that after the fact. Not doom and gloom, just soundproofing has to be done ahead of time. Sound masking and acoustic treatment should be done ahead of time and certainly considered with a design assist perspective, but it can also be altered after the fact potentially. Here's a 5-star Nobu hotel in Atlanta that we were the lead consultant on. We do all kinds of hospitals, charity redevelopment in New Orleans, an old hospital they're turning into a high school and high-rise apartments. So super unique adjacencies there that are difficult to find on any chart. Okay, and so our eye chart at the end, this is the last slide, is architects, they understand the importance of acoustics and designing for acoustics, but sometimes don't aren't aware of the implications after the fact. The complaints that we are approached with every single day of, my restaurant's too loud and I spent all my money building it. Hey, my office, I moved in and we can't get any work done. Hey, my apartment is built and I can't rent it. But usually you guys hear about that one at some point, but not so many other issues. So what we do is ABC squared. Absorption, controlling reverb and echo. We don't do it with black magic. We do it with science. Airing or Sabin's calcs. We base it on NRCs and octave band absorption. And you need that for theaters, churches, auditoriums, multi-purpose rooms, anywhere that's large and reflective. Blocking, that's your STCs and IICs. That's working smart and hard of, your studs should be certain gauges. They should be at certain spacings. Don't double layer drywall and do not use resilient channel on a demising wall. That can't be fixed. Cover, sound masking. That is open offices, libraries, hospitals, areas where people need speech privacy and they don't want to be constantly distracted by background noise. And we measure that with dynamic range and dBA readings. And finally, consulting. That's site testing, that's code and ordinance compliance. Those are those more complex issues that can't be solved over a phone call. It needs site visits. And those do come up occasionally, and we're happy to engage or to refer another consultant who's a specialist in that field. And with that, we want to thank you for attending today. My name is Walker. I'm here with Nick Cupp, and we're with Commercial Acoustics in Orlando, Tampa, and New Orleans, and providing solutions all across the U.S.